I always listen to you, Uncle Bobby.
How are we on chairs? Do we have enough back there for everybody? There's two here, and how many? We've got 3 people and 2 chairs.
That's Mark. Yeah.
What I wanted to do tonight first is to welcome Michael Woods to the group. Downs, I'm sorry. I know I don't do that.
I don't know what we're close.
Just joining us tonight. You want to tell us a little bit about your background and interests?
Currently work at Hagley Museum, superintendent of services there, responsible for physical plant. Worked for DuPont for a number of years, retired from there, and doing this as a second career. Enjoy that. Enjoy learning about new things. So
Great to have you here. We all kind of went through the introductions on the first night, so we won't repeat that tonight. Bill Schwoebel will be talking about burners, the first step in boiling water to make steam to make the cars go. Before Bill gets started, Mark Hopkins has an invite that he'd like to extend to all of our new members from the existing steam team, so let Mark get started. I think I met most of you last week. Yeah, you could start some over there. One of the things, of course, we hope to accomplish with this course is to hone your interest in STEAM and in what's going on here at Auburn Heights, and we hope that you'll consider coming out and joining us on the work nights. And to help you get acquainted with those, with what goes on, we're planning an event next week. Next week is an off week for you. We won't have any class here on Wednesday. So we'd like to invite you all to come out on Thursday night, and we'll pair you up with an existing member of the STEAM team and give you a chance to see what goes on here kind of up close. I think it'll be interesting for you maybe to meet some of the other members of the team you haven't met at this point. You can kind of get some practical experience to go along with the classroom work that you're getting here. You may see some things that you think you'd like to do, or you may have a suggestion for us when you're done. Because I think we've got one of the neat things in hearing your backgrounds is the vast variety of experiences you're bringing to this. So we hope to get you involved more, and we'd like to start that next Thursday night. So we'll begin at 7:45 to 8 o'clock if you can arrive around that time. Then after a half hour, 45 minutes, we'll give you a chance to change projects if you want to, just to see something else that's going on. And then about 9 o'clock, we'll all get together and have a cup of cider and a cookie or something and just chat a little bit. Just a casual time. So that's what we have planned. And I'd like to pass around the sheet, and please let me know if you can definitely make it, if you're a maybe, or if no, you won't be able to make it, schedule conflict or something. And then we can be sure that we've got a host assigned for you when you arrive. So we'd like to make it as much fun for you as it can be. So I'll pass this around, and does anybody have any questions?
Mark, we might say that our headquarters for the work nights is usually up in the shop building rather than down here, although sometimes there are projects that carry over down here.
Yeah, the garage, I think in the handout that I gave you, I call it the garage, and that's the building, just the next one up. Just when you arrive, just check in there, and I'll be there, or Tom, to take you to who's ever already working at that time. The regular members will be arriving a little earlier than that, and they'll already have their projects going at that point. So, any questions at all?
There's a problem, like you can't make it. Is your number available, or will you call?
Yeah, my number's on the sheet of paper, and my email. And if you put yourself down as a maybe, and you need to check your schedule or check with your family or something, feel free to give me a call or send me an email note and say, yeah, I can make it. I just want to be sure that everybody who comes, we have someone pre-assigned to you already so we can help you enjoy the evening. So I'll pass this around, so please sign up.
One administrative note that I was remiss in the first session and in the last one. If anybody needs the facilities, we have them up in the upper building. Okay. Let's see one of us, and we'll tell you kind of how to go through the shop to where they are. So. Okay, Bill?
Okay, my name is Bill Schwoebel. I've been with the group since its inception, except for the first meeting in February of 1997. And I've decided to talk to you tonight about burners. Did everyone get one of these printouts that I made without the yellow underlining like mine is, so I can remember what to say? We have a few extras if you don't have one. I'm not a teacher, so if you can't hear me, speak up. If you don't understand it, holler out if I don't see your hand up or something like that. If you don't understand what I'm talking about, we'll try. There's enough experts in here to explain it better if I can. Stanley burners are of the Bunsen type. They don't have any electrical help to make them operate. The fuel's vaporized, it mixes with air, and it's ignited. Simple as that. The earliest cars from 1898 to 1902 had a much different burner in them than anything in this collection here. What's in this collection has the kind of burners that were the reliable types. The early stuff was much different design, made out of different materials. A lot of sheet metal was used instead of cast iron. One of the students we had last year has a 1902 Stanley, and he was nice enough to bring the original burner down here to show us what it looked like, and it's amazing how different it is than anything we've ever seen or worked on. But yet it worked. The pressure tank, which the Stanleys from 1902 used two of, had liquid fuel in them, not solid. There was only one pressure tank on the earlier cars, and there was no real pilot on the earlier cars. They just reduced the pressure down to just about no pressure, and the flame burnt on the burner very low until they needed steam pressure, and then the pressure was increased on the fuel and the burner came back. And I guess it didn't work out too well, so by 1902, late 1902, 1903, they came out with the cast iron burner grade. And this is one that has not been slotted, and this is for a 10 horsepower car, I guess, Tom. It has inverted V ridges in it, and these were slotted crosswise, and the fuel came up, the vaporized fuel came through the bottom of it, through the slots, and was ignited on the top. And we'll get into that a little later on.
Do we take stupid questions too?
Absolutely.
How come there's no slots in that one?
That's one that has not been slotted.
It's like still not.
It's like it came from the foundry and had never been slotted. And
Did they just do that with a saw?
so this is a reproduction, because I don't think there'd be any real ones around anymore. They had a saw-type gadget on a milling machine, and they had a bunch of saw blades set up, and they would run the thing through, I guess on a screw-type mechanism, and it would saw the slots the right distance apart, and they might have to make 2 or 3 or 4 passes through the milling machine to cut all the slots. And then they were in the right places. This is a pilot, and you can see the slots in this. They're probably closer together than they were on this type of a burner, but the same idea. slots were cut in cast iron. There was a separate pilot in these cars, which was the same throughout the rest of the Stanleys. This is the separate pilot casting, and it ran on the early cars on the same fuel that the main burner ran on, and on the later cars it ran on a separate fuel. The early cars had a single burner only. The tiller steer cars, there's 2 tiller steer cars in the collection. They had one nozzle and one burner. The burners were smaller, a lot smaller than both of these shown up here, and they only had the one nozzle. When the 10 horsepower cars came out, they needed a bigger boiler, so they needed a bigger burner. They came out with what was called a double burner. And they advertised this. I've seen advertising from 1905. Big deal, double burner. And when the 30 horsepower cars came out, about 1908, they decided that a double burner wasn't enough, so they came out with a triple burner, 3 nozzles. And there's one car in this collection that has a 3 nozzle burner. And by 1910 or so, the Stanleys decided that it was too much trouble. It didn't really help that much, so they went back to the double burner for the 30 horsepower cars. Now, inside the burner, underneath, there are mixing tubes and baffle plates. This burner does not have the mixing tubes, but it has the baffle plates. The mixing tubes were put in here on both sides, and the vaporizer, although it was mounted something like this, shot the fuel into the mixing tube, and the fuel was shot at a very high velocity and went through the mixing tube and sucked air with it. When it got to the end of the mixing tube, it came out and it swirled around. And if those plates weren't there, it would all get sucked up there. So it swirled around and spread out, and it went up through the grate over the entire area. Also, there was, on the bottom here was a sheet metal plate that was shaped like the bottom of the grate, and it was crimped over around the edge. And it was, in fact, sealed with a cement, like an iron cement. And this was very important. You wanted all of that fuel to stay under the grate. You didn't want it leaking out somewhere around the edge, because then it could cause a backfire. And maybe none of you have been in a car when it backfired, but it's quite an experience the first time it happens. Burners came in a lot of different sizes. The early cars, the tiller steer cars, started out at 14-inch diameter and 16-inch. When the 10 horsepower cars came out, they went to 18-inch. And by the last year, they made the 10 horsepower cars. They decided 18-inch wasn't big enough, so they came out with a 20-inch burner for a 20-inch boiler. The 10 horsepower cars had become big and heavy, and they needed that extra capacity. The 20 horsepower cars used a 23-inch burner for the 23-inch boiler, and the 30 horsepower cars used a 26-inch burner for a 26-inch boiler. Twin pressure tanks, as I spoke of earlier, were used for the fuel. This is one of the pressure tanks. There was no pressure in the main fuel tank. The pressure was kept in these small tanks. One was filled with fuel and one was filled with air. The air was called a cushion. It was put in there to push the fuel to the burner, and it kept the strokes from the power pump showing up as kind of a jerky motion for the fuel. And we'll talk more about that later on. There was a hand pump for the fuel and a power pump. The power pump only operated when the engine operated. The engine only operated when the car was in motion. So if the car was going very slow and you had to keep the pressure up for the fuel, you had to hand pump it. fired up first thing, you had no steam to run the engine, so you had to use the hand pump to bring that pressure up so you could fire up the car. There are also check valves throughout the system. We have one here. There's a ball in there that lets the fuel pass in one direction only to keep the fuel going in the one direction it's supposed to go in. And of course, there was a filter or two in the car, either at the main tank or somewhere along the line, which was probably no more than a strainer. There's an air recharge valve in the systems to put the air cushion in the pressure tank, and also to put air in a pilot tank if the pilot tank was used for fuel. Welcome.
Hi. Sorry to be late.
There's a handout here already,
Is
Bill.
there a handout there?
Yeah, there's a handout right on that chair.
Hey. Bill, how do you get the fuel into the pressurized tank from the unpressurized main tank?
Well, the pump would pump it in, or the hand pump would pump it in from the main tank
The pump is operating directly on the fuel.
on the fuel line. And we'll talk about that more. This is really an explanation of what parts were on the car. There's a fuel automatic, which is this little item here, which when the pressure of the fuel reached a certain stage, a maximum, this opened up and bypassed the fuel back to the main tank. When the car is operating and the steam pressure reaches a maximum, there's an automatic on the steam that shuts the fuel off going to the burner, and if you're driving along, the pumps are still pumping because the engine's operating with pumps. And that pressure, that fuel fills these tanks up, and when it reaches a maximum, if this wasn't there, you'd have a problem. So this opened up then and bypassed the fuel back to the main tank. And then when fuel was needed again, this would close and the fuel would go through the burner. Page 2.
Is it sensing steam pressure, not fuel pressure?
Steam pressure, I said, yes, I talked about steam pressure, but it's the steam pressure that in the steam automatic that I haven't gotten to yet that kind of controlled what this did. On the early cars that used the early type burner there, the pilot ran on the same fuel that the burner ran on. And it ran at a fairly high pressure, the same pressure that the main burner ran on. And that was a problem because the pilot nozzles would tend to choke up from the high pressure and the carbon. I've written down here what the main burner nozzle sizes were. It's not important now until you get down to the other type of fuel system, and when you compare them, you'll see they're different. The cars all had a burner hood over the boiler and burner, and a stack and a flue. And so the burnt gases from the vaporizer didn't smell up where the operator was. And the flue went down underneath the car and exited out the back of the car. And if you were traveling along, you really, at least with the gasoline models, you didn't get that odor. But with the kerosene models, you do get, by the end of the day, you do kind of smell like burnt kerosene, which isn't the most pleasant smell in the world. All right, in 1913, late 1913, for the 1914 models, they decided to change the fuels. They changed the main burner to operate on kerosene. And it was the 1914 models that were equipped this way, although Tom has said that it happened in late 13. Do you think any of the 13 cars came through that way?
They didn't have a built-in pilot tank in 13. Well, you'll go on to say that many of the earlier cars were converted to kerosene.
When this came out, a lot of people liked this idea and wanted this idea to be put on the earlier cars. So a kit was made by the Stanley Company to equip earlier cars with a later type fuel system. The burner grate had to be changed. This type of burner wouldn't work with kerosene, so this type of burner was created. Instead of the ridges being pointed, they were flattened out. And they flattened them out, and then they drilled thousands of tiny holes in them. And the kerosene vapor seemed to go through these easier and burn better. So all the burners after 1914, from 1914 on, were of this type. 1914 only had one 10 horsepower car. That was the last year for it, so that was the only year for the 10 horsepower burners to be this way. But 20 and 30 horsepower burners were this way. This burner, in fact, is out of a 1916 Stanley from the collection, which is the earliest condensing car in the collection. There was a vaporizer, and I didn't talk about the vaporizer. The early vaporizer, gasoline vaporizer, was of this type. Gasoline doesn't need much heat for vaporization. So this went directly across the burner like so. This is not for a 20 horsepower burner. And only this much of the pipe was exposed to the heat. The center pipe was the pilot vaporizer. And this is a later gasoline version. They found that the pilot got too much heat all being in a row like this, all exposed to the fire. So when this one was made, when it got near the nozzles, they put it on top of these two pipes. And that was cooler up there, so it didn't vaporize too much when it finally got to the nozzle. When the kerosene models came out, they were a bigger vaporizer. Kerosene is a heavier fuel, so it needed a bigger vaporizer to vaporize it. And this is the vaporizer from the 20 horsepower burner here. It fit, well actually it fit through this side. I'll just set it there. But it fit on top of the burner itself, between the burner and the boiler. The boiler would have set right down to the top of this. So this space in here, which is about this deep, is where the vaporizer lived. And the fuel came in this end. Actually, it's supposed to be this way, because here's where this pipe comes out. The fuel went in here and went all through all that piping before it finally came out and went through forks and nozzles were here, into the mixing tubes. And inside of this tube, which is the vaporizer, was a cable.
You can pull that one right out, Bill.
Oh, is it in there?
Just unscrew the end.
Yeah, there it is. Have you had it out?
Yeah.
So it comes out? There's a cable that runs about 2/3 of the way through. And the reason for the cable, and it was on all of these, it was on the earlier types and the later types. The cable is inserted in there basically to make the fuel stay on the outside part around the cable inside the tube, which is the hotter part of the inside of the tube. And also, if you had problems, the cable could be pulled, and with it a lot of carbon would come out. Sometimes it would tend to stick in there, and then that was a problem. But some of the fellows that run the cars today on a different fuel than kerosene have to pull the cable frequently, maybe once a day.
Is that copper?
No, it's stainless steel. But in the early days, it was not stainless steel. There was some talk about a nickel iron or something that was
No,
used.
I guess, I don't know.
Maybe nickel plated?
Cable probably was just
Yeah.
steel cable.
Yeah, I know they use stainless steel cable too today, which can be gotten from a marine supplier. The pilot Pilot, yeah. 46 years old and my voice is still cracking. The Pilot lived in here. And on this model, it was easily removable, which was quite a difference in the earlier models. The Pilot ran on a separate fuel than the main fuel. The Pilot ran on, in those days, gasoline. Today we use either Coleman fuel or a type of fuel that's really not a fuel, it's a solvent called hexane. Hexane is wonderful for the Stanley Pilot. It doesn't carbon up at all. It's very low in hydrocarbons, and when you run on a tour with it, you go to clean out the nozzle, but there's a, well, I'll talk about that later. There's a pin in the nozzle that you pull out usually in the morning before you fire it up and wipe that off with your fingers. And with hexane, there's no residue at all on it. There's a firing up valve. Well, I'm getting ahead of myself here. There are forks on this. These are the forks. The earlier cars had something similar, but they were part of the vaporizer. The vaporizer tube was bent at the end, which was on the outside of the car, and the nozzle was down here. And the nozzle, in fact, even was part of the casting. There was a clean-out screw on the front that could be taken out, and the nozzle could be cleaned with a wire the same size as the nozzle. There was a screw on the bottom, and the drill could be put up this far, or a wire could be inserted to clean out there. And a lot of times you couldn't clean out very much with it. Later designs came out with what we call forks. There was a cap screw on the end of the vaporizer that held the forks on. And the forks could be removed easily, although this one wasn't that easy to remove. And you see screws in various corners of the forks that are removable, and then drills or wires can be put in all areas so you can clean it out easily. And this started when the kerosene vaporizers started in 1914.
Just a slight correction. This is the type vaporizer they would have sent you if you said you wanted to burn kerosene in an earlier car. And I believe this is identical to the one in the Maudi car up there. I think this is exactly like yours, Gerhard and Gene. I think you'll find your vaporizer comes through the burner, left side, so I think that is probably exactly. And since they figured, excuse me,
It's all right.
since they figured they were getting too much heat on the Pilot vaporizer anyway, Bill mentioned how they brought it up on top here. They decided, well, there's no use running the Pilot all the way through, so they came up through the bottom of the burner and just had the Pilot for about 6 inches in the fire there. That's the first type, and this really has no decent cleanouts either. It does have plugs in the bottom, but you can't get around these curves very well to clean out, and that's why the forks came along a little bit later.
Is the clean out so important because the kerosene is dirty compared to gasoline?
It will carbon up. It's a problem with these. There's the different heats and the way the fuel's made.
Over the years, good fuel has been, or poor fuel has been one of the major problems to running these cars. And I've gone through the cycle 2 or 3 times with good kerosene being available and poor kerosene being available. It was almost phased out back in the late 70s, early 80s. And then the kerosene stoves came on strong, and they started to talk about K1 and the water white kerosene. Then we started to get some pretty good stuff again. And it is good, but when you're on a trip somewhere and you buy it at a store or on the road, you really don't know what you're getting, and that can cause a lot of carbon. That's why we have the cleanouts.
I wonder if anybody ever tried JP4 jet fuel.
Yes.
High class
It's
kerosene.
expensive, Ed, but I have bought jet fuel a couple of times on the trip.
Hmm.
Yeah, it
pilot design changed slightly. In this design, the pilot had a very long vaporizer, as we spoke about, and then, like this one that Tom showed, wasn't nearly as long. This is an earlier type than this. And the later design, this little U-tube is the vaporizer. This was enough to heat the gasoline, or today hexane, enough to vaporize it to burn in the pilot. And there's a picture in your pamphlets in the back of one similar to this, although it has a V-shaped tube. This burner has a plate on the front, which is like this, so that the pilot can be removed from the front, which is a big help, because periodically the pilot you have problems with, and the early cars you had to drop the whole burner to get the pilot out. But when they came out with that plate design, which wasn't really until the 20s, and a lot of people have put them on their earlier cars just to make it convenient to get the pilot out.
When we talk about the picture of in the pilot, is the fuel coming in this longer tube and going reversing and coming out?
The fuel comes in from this tube here, which is the longer tube, goes into the fire. There's fire coming out of these slots in the pilot. Is vaporized, comes out, goes down. This pipe is called the down pipe, and then it goes through the nozzle. And I'm going to explain this in a little while, but there's a little wire in the nozzle, which I'll get to in a minute. Let me finish the pilot tank pressure now, since it was on its own separate system, was between 15 to 35 pounds. The lower pressure helped quite a bit in keeping the pilot nozzle from carboning up. Kerosene had quite a few advantages, more than gasoline. If there was a problem with it leaking out, either a fuel line or something breaking, if it did leak out, it didn't explode like gasoline did. It had more heat because it was a heavier fuel, more BTUs out of it. It was sometimes easier to find even than gasoline because it was used for lighting in those days. And the one that my father would enjoy the most, it was cheaper than gasoline, although it was only 6 cents in those days for kerosene a gallon. But 11 cents, I'm sure my father would have been very upset if gasoline was 11 cents. The only bad thing, as Tom always said, was the odor when it burnt. It does kind of get to you. It gets all over your clothing when you come in from a long day of touring with a kerosene-fired Stanley. You kind of reek of kerosene. Okay, the pilot. Now I get into the pilot. It's the small burner that works together with the main burner. It's a separate casting, and you can look at that picture in your literature there. And it lives right on top of the main burner, and it burns continuously. It has a nozzle at one end. There is a hole in the front of the casting, and inserted in that hole is what's called a mixing tube. The mixing tube goes about 2/3 to 3/4 of the way down inside the casting. And when the fuel goes through the vaporizer and goes through the nozzle, it goes through at a very high velocity because it has all this pressure behind it, pushing it. And going through there at a high velocity, it draws with it a bunch of air through the tube, the mixing tube, which mixes in the mixing tube and comes out the end and goes up through the slots. And when you fire up, first thing, you heat this up, and then you stick a torch in what is called a peephole, air in the burner and ignite this. Once it's ignited, it burns the whole time you're using your car. The main burner may go off and on, but this stays lit all the time. And one of the most important things to do with this is to keep it burning with a strong flame. If it gets a weak flame, it can blow out, then you have other problems created with fuel going into the burner, no fire there to ignite it. So this has to be kept burning as optimally as it can. There is a screw on the back side of the downpipe behind the nozzle, and when that screw is taken out, this one's tight, on the end of that screw is a piece of wire. And if you look closely at the picture, you sort of see the piece of wire coming out the end of the nozzle. That piece of wire basically shuts off the size of the nozzle. And what has been done with that piece of wire, I guess you can sort of see it on this one, sticking it, you get good eyes. What has been done with that piece of wire, it's been filed off slightly on one side. There's a flat that's been filed onto it. And it's that little space is just enough for the fuel to be shot through there into the mixing tube and make this burn at an optimal way. If that is filed too much, it won't burn, it'll burn too rich. If it's not filed enough, it'll burn too weak. So that's a very important thing. Once that is done, then everything's fine. The only thing that might have to be changed is the way this is lined up with the mixing tube. If it's too far away, it won't, not enough air will go through. If it's too close, the opposite's true. So if I had a screwdriver, I could take it off, but you couldn't see the filed off place anyway, so it doesn't really matter.
How long does that wire last?
Almost indefinitely, I would say. It's probably a piece of piano wire, isn't it, Tom? It's very hard so that it doesn't lose tempers. Most of the cars have one on it that looks very old. There's a taper at the bottom of the screw that fits against the taper on the casting here so that it seals it off when you screw it in. One of the things you have to do periodically, if you look through the peephole here, there's a little cover that slides across that so that covers it up so that when you're driving along it doesn't blow it out. You open that little peephole and you look through there and you can see the pilot burning. And if the pilot looks a little weak, doesn't have a real blue flame, strong blue flame, you put a screwdriver on this screw and you crack it open a quarter of a turn to a half turn, and you do that 2 or 3 times. And what that does, it dislodges any carbon that's on that wire. And then you can look through there and see it, and it should be burning nice and blue brightly, which is what you want it to do. And we call that tickling the pilot. Probably bigger too. Since the main burner doesn't burn all the time, as demands for steam vary with the conditions of the road, the system is so designed to adapt itself to these conditions. So when the main burner goes off, the pilot stays lit all the time. When fuel comes back into the main burner, because you need steam, it gets ignited because the pilot's always burning. And there is this item is the next one on our list. This is a steam automatic. This turns the fuel on and off. When the steam pressure gets to its maximum, this shuts the fuel off. It has a valve at the bottom that the fuel passes through. And when the pressure reaches its maximum, which could be anywhere from 500 to 600 pounds per square inch, the pressure of the steam turns the valve off and shuts the fuel off so the fuel doesn't go into the burner. And when the fuel doesn't go into the burner goes out. But the pilot's still there. When there's- sorry.
The fuel flow is either on or off, there's no throttle per se for the fuel.
There's a throttle, but it's only for the steam. This controls the fuel going to the burner. Yes, sir.
There's a burner valve that feeds that, which is like what he's talking about, a throttle for the car.
There's a burner valve, yeah.
If you're in
Yeah.
traffic and going through a city with a lot of traffic lights, rather than having your hand valve wide open and letting this automatic off and on, you can cut it back on your hand valve so it doesn't shut off so much, where you don't need the maximum steam.
But this can fluctuate quite a bit. It doesn't wait till the pressure is down to 400 pounds to open up. If it's set to shut off the fuel pressure at 500 pounds steam pressure, as soon as it drops to 490 pounds or 475 pounds of steam pressure, this will start to open up this valve on the bottom. And it won't let a lot of fuel through, but it'll let some fuel through. As that steam pressure keeps dropping, this will open up even more and let more and more fuel through until it gets to the lowest part, which is around 400 pounds steam pressure, and then this is open all the way. And then again, as steam pressure builds, it works on the diaphragm. There's a diaphragm up here between these screws, which is just a thin brass plate. It's brass, isn't it?
Some brass, some copper.
When the pressure starts building on the top here, it presses against the spring, which presses against the rod in here, and it starts shutting the fuel pressure off. And when it reaches 500 pounds or 600 pounds or whatever it's set for, it'll shut it off completely. And this goes on continuously while you're operating the car, and it keeps the operator from having to worry about it. You can turn a main burner valve off on the dash manually, and if you're not watching, the pressure will just drop. The steam pressure will just drop as you're using it. But if you don't do that, this will watch it for you. And they're very reliable, and they were on the cars basically from the beginning. That 1898 picture, I think there's a drawing in there of an 1898 Stanley locomobile, and it has a valve in there very similar to this. So this must have been invented or put on the cars in the early days. I don't know whether it was really invented by the Stanleys, but
They have a patent on that thing.
do they? Okay. So that's the steam automatic, and this was usually mounted on the non-condensing cars on the firewall outside the boiler in a position vertical like this. The main burner supplies energy that drives the car. Fuel's carried to the main from the main fuel tank at atmospheric pressure, and it's drawn by a small power pump. These are pumps mounted on a pump board, which is very similar to what's in the cars. These two pumps are water pumps. This is a fuel pump. And what is missing here is the plunger rod for the oil pump that puts oil into the steam for the engine. And this is operated off a rod that goes to the wrist pin on the steam engine. And every time the engine makes a revolution, it moves this back and forth. So these pumps work all the time, all four of them. We're only concerned tonight with the fuel pump. That is the one power pump for the fuel. There's also a hand pump that's in a different place under the floorboards of the car. And there's a hand-powered fuel pump and a hand-powered water pump there. And there's a lever that comes up that can be operated by the operator driving the car. When you're driving along, this is fine. This gives you enough fuel to the pressure tanks. Actually, it gives you too much fuel to the pressure tanks. When you're going real slow, it doesn't give you enough, so you have to use the hand pump to keep the pressure up. there's a gauge on the dash that shows you what the fuel pressure is. If the fuel pressure becomes too great, there's another little controlling item here called a fuel automatic. If the steam automatic shuts the fuel off to the burner and you're still driving along and the engine's operating the pumps, in no time at all the fuel pressure is up to the maximum. When it gets to the maximum and the burner doesn't need it, this device is on there. This then opens and bypasses the fuel back to the main tank where there is no pressure. And that is, I believe, on all the cars too since the beginning, basically. And that's usually located under the floorboards with the pumps. And then there's a little thing in here about if it's a kerosene powered car, you can put fuel in the main fuel tank anytime. If it's a gasoline burner car, you shouldn't do it when the fire's on. But all of you should know that. Fuel pressure on the burner, the main burner, could be anywhere from 80 to 140 pounds, depending upon what your standard car you have. The earlier cars that burnt gasoline and used the lighter fluid, the pressure was usually around 80 pounds. When they switched over to kerosene, the heavier fuel needed higher pressure to force it through the nozzle, so they had to increase the pressure as far as 140 pounds. There's an air recharge valve in the system, which is one of these. It was attached to the dash. And what you could do with this was add air pressure to the pressure tanks. The pressure tanks were located somewhere on the car. There were two of them. The originals were steel. The reproductions are copper. They were mounted side by side. One had fuel pumped into it. The other had a cushion of air pumped into it. You had to replenish this cushion of air, and this was how you did it. This was mounted on the dash. You put a hand pump, which is what they used in the early days, to this valve. You opened this up, and you pumped air into the tanks. Usually you had to wait till the pressure was down to 80 pounds or so before you could pump pressure into it. You wanted a cushion of air in there, you pumped it up to, you pumped 40 pounds of air in it. And then you drove along and you watched your fuel pressure gauge. If the fuel pressure gauge stayed constant without vibrating, you knew you had enough of a cushion in there. If it vibrated, you didn't have enough cushion in there and you had to do this again. Sometimes you had to do it as often as 3 times. When you drive the car on a tour, you have to do this every couple of days. Now, the fuel is finally, it's been pumped out of the main tank into the pressure tanks, and now it's headed towards the burner. Now you've got some other things in there. You've got a hand shut-off valve, you've got a pressure retaining valve, you've got a low water automatic, a steam automatic valve, and check valves. And we've talked about the fuel automatic, the steam automatic. The hand shut-off valve was put in there, and this was on the dash, usually to the right of the steering column, down near the floor. This was put in there in case you had trouble with some of these systems. You could shut the fuel off, and then you could work on the system without losing the pressure in your pressure tanks. There's a pressure retaining valve in there, and that was on the floor to the right of the driver's feet near the body. And this was put on, it's a valve similar to this, it's a needle valve without the adding on pressure place. And it was put on there to take the pressure off the pumps while the car was sitting. It kept it in the tanks, but it relieved it from the pumps because it could leak out of packing in the pumps around the shaft. They found out later on in the 20s that this valve wasn't needed, so they didn't put it on the cars after that. But all the early cars pretty much have that valve. And when we drive them somewhere and we get where we're going, we'll close that valve. And that'll keep the pressure that's showing on the fuel gauge. This device is called a low water automatic. The fuel went through a valve at the end here on its way to the burner. Then this was mounted on the side of the boiler, on that side, I guess. But anyway, it was mounted like so, about 4 inches from the bottom of the boiler. And it was mounted so that water would enter the bottom of it and fill this center tube. The center tube was brass. The outside rods are steel, and they're holding it in this position. The water would go in there, and the top end of the tube is closed. And this being on the outside of the boiler, it stayed cooler out here. And as long as there was water in this tube, this valve would stay open up here, and fuel would flow through it, headed towards the vaporizer. If at any time the water in the boiler dropped to the 4 inches or below, it would uncover the bottom of this tube, and the water would drain out and steam would fill that tube. And when that happened, that tube would expand, and that would push the plunger and close the valve, so that you didn't run out of water in your boiler. The burner would quit, and you'd have to stop and figure out what happened. These are great devices, but we're not always sure that they work because we don't want to find out. We like to keep the level in the boiler above 4 inches, so that's a safety feature on there. The fuel automatic I've talked about, the steam automatic, I hope I've explained that well enough. There are gauges on the dash for the fuel pressure. The early cars had a single gauge because the pilot and the burner were all on the same fuel. The later cars that burned kerosene in the main burner had to have 2 gauges because they had 2 different fuels. You had one for kerosene, it was usually a fairly large gauge on the dash, and then there was a smaller gauge near the outside of the car, or the left side of the car on the dash, that showed pressure in the tank for the pilot fuel. I don't think I've talked about, the pilot had its own separate tank on the kerosene-fired cars for the pilot. It was on the early cars that had the 2-fuel system, it was a copper tank mounted outside of the car on the left side near the running board. And it held as much as 3 gallons, and the pilot would burn for a couple of days probably on 3 gallons of fuel. And you had to put pressure into this tank with a air adding valve similar to this, and the gauge was mounted right on this valve, and you could pump the pressure up and watch the gauge rise, and when it got to the maximum, you closed this valve. It would stay there for quite a while. You might have to add pressure to it once or twice until you had to refill it. Okay. The vaporizer. When the fuel finally gets to the burner, it must be heated to vaporizer so it can be burned. It's pumped through the vaporizer. Through this is the vaporizer. We spoke about that. This has a cable in it. We spoke about that. And it's very similar to the pilot with the nozzles here. Once it goes through, well, this doesn't sit. I'm going to try putting this back the way it's supposed to go.
I don't think you can get it
Can
in.
you get in there? Okay. Well, anyway, this end goes through here, and the forks live right in here. take them off and hold them there. The forks would live right here, like so. There's a space down here between the nozzle and the mixing tube. And the fuel went in here and went through the vaporizer and came out here, came down the forks, and was forced at very high velocity through the nozzles here. And when it went through the nozzles, of course, it drew air with it, went in there, and as we spoke about this, underneath this is a plate over the bottom of the burner itself, and it swirls around under there and eventually comes up through the holes, and then the pilot lights it on top of the burner. These holes in the nozzles are a certain size for the kerosene. The earlier cars, of course, had the shorter vaporizer. The later cars had the longer vaporizer. The nozzles unscrew out of there and they can be cleaned. The earlier cars, they were part of the vaporizer. They could not be taken off to be cleaned. So this all helped when it was time to clean them out. And one of the things we do before we drive the car anywhere is usually take the nozzles out and clean them. Smell the kerosene.
When you light your burner, after the pilot light's lit, do you have to actually heat the forks
Yep.
to vaporize it?
Yeah, that's in the firing up sequence in this. But the pilot is heated up first. You heat up what's exposed. This part is exposed. You put a torch on the casting here and the inlet part. You heat it for a minute or two, and then that's usually hot enough. You go and you turn the valve on, and the fuel goes through, and you stick the torch in the peephole and light this. It burns kind of weakly. It burns weak for 4 or 5 minutes, but as it heats up, it starts to burn better. You might have to tickle the pilot once, but in a short time, it burns well. You could just leave it burn there for half an hour, and that would heat the vaporizer up enough to start the vaporizer, but nobody really wants to wait half an hour, so they get a torch and they start heating these forks. You heat where the fuel goes in, and you heat the forks up on the top here, and after 3 or 4 minutes, then you can usually start to light the main burner, and that's another story. If we have time, we'll get into that, but I want to try and finish the rest of this. The valves for controlling the operation of the burner. They're all arranged on the Stanley car within easy reach of the operator most of the time. They all had different length stems. There's a picture there, the first picture I think, but it really doesn't give you any idea of the length of the stems. It just kind of tells you where they are. And that picture is for gasoline-powered cars. There's no firing up valve. This is another valve that is part of it. Usually the longest handle valve is the main fire valve for the main burner. The next longer in length is probably the pilot valve. There are other valves. There are water control valves that are either on the floor or under the steering wheel, water bypass valves, and the like. I do mention in here the cars that had 3 nozzles and 3 mixing tubes had 2 valves for the main burner. One of the valves controlled 2 of the mixing tubes, and the other valve controlled the 3rd. And I guess you could run it in 2 nozzles if you wanted to, but I don't know how good an idea that would be. The pilot valve on non-condensing cars was down near the floorboards on the left side of the dash. On condensing cars, it was outside under the splash panel on the left front fender, which was easy for you when you lit the car with the pilot. It was right there. You could just turn it on and light the pilot with your torch. With the non-condensing cars, you have to go around the dash, open the valve, go back around, and light the pilot. Pressure retaining valve, I pretty well explained. It's down at the floorboards on the right side, under your feet, near the right side of the body on the non-condensing cars. The fuel shut-off valve is located to the right of the steering column usually. And then there's a firing up valve, which is on the kerosene burner cars. When you fire up a car with a kerosene burner, you can't put kerosene right in there right away. And that's why I brought the Coleman lamp. Many of you know Coleman lamps, but not too many of you know the type that burn kerosene. Well, this is a kerosene burning Coleman lamp. And it has a little cup right here at the base of the generator, it's called. And you fill that cup with, I always fill it with wood alcohol, but you could fill it with gasoline. You fill that cup, you put pressure in the tank where the kerosene is, and you stick a match in there and you light that little cup. You light the fuel in that little cup. And that burns, and as it burns, it heats up the generator. Well, that's really what you're doing here. When that generator heats up enough, that cup will just about be empty, and then you can turn the valve and light it, and it'll light like that, because now the generator's hot, and the fuel that's in that generator will turn to vapor and ignite. Well, with this, very similar. You heat the forks in the front and get them nice and hot, and you go in the car, and there's what they call a firing up valve, and that's a valve on the pilot system, which is gasoline or hexane. You open that valve once and close it, and that puts pilot fuel in this vaporizer. Well, pilot fuel vaporizes real quick and ignites right away. So after 2 or 3 shots of that, the pilot will light the fuel in the main burner, and it'll start to heat up the main burner. And after a while, you can leave that firing up valve cracked, and that'll cracked open, and that'll put pilot fuel in the main burner, and as I said, warm everything up. After everything's warm, then you can shut that off and go to kerosene, and you can start giving it shots of kerosene. And not always can you do that continuously. You might have to go back and give it pilot fuel and alternate back and forth. And finally, when the burner's warm enough and it's starting to vaporize the fuel, the kerosene fuel, then you can just give it kerosene. And you can look up front here where the forks are, and as that fuel is shot through those nozzles, you can look at it. And if it's wet, it'll be like a spray. You'll be able to see the vapor. As it warms up, that vapor will start to turn into a gas, and you won't be able to see it anymore. And when you can tell that it's now a gas, then you can pretty much continue to use kerosene to warm everything up in here. And when it starts to run continuously on kerosene, then it'll start building pressure up in the boiler. It'll start to boil water, which is the idea. Okay. Now the next part of this lecture is about firing up. And I had hoped when I did this, it would be warm out and it would be dry out and we could fire one up, but we don't have that happening tonight. So if we have time, maybe when it's over, maybe we'll light a pilot in one of them. At least you'll be able to see how you light a pilot. As the course goes on, I'm sure one of these nights we'll have daylight saving time and we'll be able to fire one up in the daylight for you. But that's just not going to happen tonight. So we'll move ahead to problems that burners might have. Some people, not everybody, but the older generation that has seen Stanley before might remember hearing a Stanley blow up. Well, they probably didn't hear it blow up. They probably heard a burner explosion. And this can happen, and there are reasons for this to happen, but it's quite a blast. It really sounds like there was a problem, and when it happens to you when you're operating one, it's quite a shock the first time it happens. But the reasons it could happen were, as I explained in the firing up process, by putting pilot fuel in the vaporizer. When you switch over to kerosene, if you switch over too fast and put kerosene in the vaporizer and it's too wet, instead of burning on the above the grate, it'll collect under the grate, and it'll just pool down there. And finally, when everything gets hot enough, then it won't do that anymore. It'll start coming up through the grate because it'll be a gas. But that fuel will lay down there underneath the grate until everything heats up enough, which might not occur until you're driving down the road. And all of a sudden, the thing will explode. And if that happens, you've got to quick pull over and turn the main burner off and the pilot burner off and get that hood open as soon as you can, so that those flames, because you'll have flames coming out around the burner everywhere that there's a place, and they'll burn the paint off the hood if you leave the hood down. So the idea is to get that hood open and just kind of let it burn out. And if you happen to be at a convenience store or something, you're going to get a lot of people upset, but it will eventually go out. A friend of mine had one do that, and he really had to talk to the people hard about keeping the fire department from filling it, covering it with water. But there are other reasons why this could happen. It can be caused by a crack in the burner grate. Sometimes these grates get cracks in them, which will let more air pass through, and a backfire can occur from that. If that happens frequently, if the car is equipped with what we call a stack blower, which was not a standard feature that Stanley put on, some of the later owners have put them on, which shoots steam into the stack or the flue and creates a better draft, and this can be done, and it will relieve that problem of a cracked burner grate. But it's a problem that has to be repaired, and the burner will have to be dropped, and you'll have to find out what the cause is. Could be a leak around the top here where the burner is pushed up and held up against the boiler itself. That could cause a backfire. There are other items in here besides the vaporizer. There's what we call a superheater, which will be explained to you when Bob Wilhelm does his little talk, but that's when the steam is turned to steam in the boiler, it comes out of the top of the boiler, and before it goes to the engine, it goes through another pipe down in the burner, which is a superheater, and that superheats the steam, makes it expand even more, so that when it goes to the engine, you get more power out of it. And if that's cracked, that could give you a problem with backfires. And also, just a clogged nozzle. These nozzles up here get choked up with carbon, and they should be taken out. They should be taken out before you drive anywhere in the morning. And sometimes on the road they can choke up, and you have to take them out, and then they're hot when you do that. Or you can, some people carry, we usually carry with us a little pricking wire, and it's on a little handle, and you can stick it back there and prick that out. That usually opens it up, and that cures that problem. The pan that I spoke about on this grate, which is on the other side, on this side, it's crimped around here. If that creates a leak, if it gets cracked or rusts through or something, that can create a backfiring problem. And to fix that, the burner has to be dropped. And the one thing I didn't talk about, and I should have talked about, if you notice on this burner, there's two layers of sheet metal here. One's called the outside burner pan and the inside burner pan. And that's done to basically insulate the burner grate from the outside. When these are operating, you really can't touch these, but they're fairly cool. A lot cooler than they'd be if there wasn't this arrangement. And this is all insulating material between. And underneath the burner, see where this plate was that's attached to the bottom here, there's also insulating material between that and the bottom of the outside pan, insulated. So there's insulation all around. You'll notice inside here, this stuff in here, it's also insulating material between where the holes are and the grate itself. Also helps to cool everything down. The earlier ones, it would have been put in these places here, so that this would have been flat across the top. That would have all been filled up with insulating material. Could be carbon choking the pilot nozzle, and to cool that, tickle the pilot, which is backing that little screw out on the pilot here, a quarter to a half a turn, 2 or 3 times, and that's enough to jar loose any carbon that's choking up that little orifice there. The nozzles can be choked up. The answer is to take them off and clean them. If that doesn't cure it, the forks can be choked up, and they can be cleaned through these cleanouts, or it can even be taken off the front by taking this cap screw off and cleaned. If that doesn't cure it, there's a cable, as I said, inside of the vaporizer. Last resort is to pull that. And when you do that, you should get a lot of carbon on the outside of the cable. And you can also take it and rub it in and out to clear the carbon. If you do that, though, that's really a last resort. It's nice to be able to do it when the burner is cool, because if you're not careful, you'll burn yourself, for one thing. But then, if it's cool, then you can run fuel through it after the cable is out, and hold a cup or a can or something out front there at the ends of the burner forks, and when that fuel goes through, it'll pull a lot of that carbon with it. And then you can put everything back together. Of course, when you fire up the next time, you'll have a lot of flames around there because of the fuel that you didn't really get soaked up. But it is a good way to clean everything up.
Can you use compressed air for cleaning?
Well, there is another, yeah, you can use compressed air. You can take the fittings off the back end, which on this one is right out front. On the early ones, it was back here. But the later ones, it was right out front where the forks were. You can take that apart and blow compressed air through. Sometimes the cable gets actually attached to the vaporizer, and things really get bad, and then you really do have a serious problem. There is a problem with a howl. Some of these burners get, the nozzles get drilled out a little too big sometimes, and there's a continual howl when they operate. On the first tour I was on in Canada, there was somebody there with a 735 condensing car, and every time the car went past us, it was howling when the burner was on. I don't know how that man stood it. But a lot of these cars do have a little slight howl when the fire's on. In some respect, it's good to hear that because that tells everything is open and operating properly. If it's a continuous thing, it gets annoying, but if it's for a short time, it's a good sign. There are modern changes for the fuel system. A lot of the people today have found that kerosene is a hard thing to find along the road, a lot harder than it used to be. So people that don't have a car that ran on gasoline will use diesel fuel and gasoline as the fuel. When they do that, there have to be changes made to the vaporizer and the burner itself. The vaporizer has to be changed in length. The kerosene vaporizers were anywhere from 7 to 8 feet long. And I'm not really sure of this, but I think Art Hart said the length had to be decreased to around 6 feet. But don't quote me on that. The vaporizer should be Schedule 40 stainless steel pipe, 1/4 inch inside diameter, and a 3/16 inch stainless steel cable should be used inside of it. And it should go completely through the vaporizer. So it can be inserted from where the nozzles are instead of at the back end. Fuel pressure, since diesel fuel is heavier than kerosene, has to be increased to about 160 pounds from 140 pounds to force the heavier fuel through the nozzles for combustion and draw enough air with it. The nozzles have to be changed in size, and the mixture should be 60% diesel fuel and 40% gasoline. And since not every burner is exactly the same, this will have to be adjusted too. If you have a chance to use this, you might have to go to 65% diesel and 35% gasoline. And as I remember, Art Hart said you had to put one of the fuels in before the other. I think you put the gasoline in first and the diesel on top of it. If you don't do that, it won't mix properly. And if you have a fuel tank that's partially full, then you've got to kind of guess at how much to put in. Art Hart had a stick, and he knew exactly how much fuel was in the tank, and then he could figure how much to put in. But a lot of these fellas won't do that. They'll just kind of guess. And then the burner won't really react as well. And the wetter fuel, when it goes into the burner, the wetter the fuel is when it goes into the burner, the better the chances are of not carboning up the vaporizer and the nozzles. And this is exactly the opposite of the way we've been taught down here. All the times cars burn either gasoline or kerosene. None of them have been switched over to this design. And we've always been told the fuel has to be dry when it goes into the burner to burn properly. And now they're telling you, when you use this other fuel system, that it should be better to go in wet. So that would take some getting used to, I would think, at least for me. When things do tend to carbon up, the vaporizer especially, and instead of getting pieces of carbon in there, it tends to carbon up from the inside surface of the tube, from the outside of that in towards the cable. And with this in mind, the cable has to be pulled at least every day to clean that carbon out of there. And the nozzles, I guess, have to be cleaned out frequently. One ingenious owner, as I put here, put what they call a steam enema valve on the vaporizer, which is a valve off the top of the boiler run down to the back end of the vaporizer. And what you would do would be you would take the cap off and remove the cable, and then with steam pressure in the boiler, open that valve up, and that would shoot steam through the vaporizer, and that would, the heat and the velocity of the steam would tend to clean all that carbon out. just remember to take the cable out before you do that, or it'll end up a mile from where you are. Any questions?
Well, this isn't a question, but I think when they're talking about wet fuel, they're also talking about Baker burners and not a Stanley type burner.
Oh, really?
And so many variables here. You know, you talked about mixtures of fuel, lengths of vaporizer pipe, and it's only confusing at this point, I guess. But every burner is a little different. Every time you stop along the road to buy fuel, it's a little different. So all these things do affect the working with the burner a little bit.
Yeah, this last tour we were on, they've added a dye to the fuel, to the kerosene. And although it didn't seem to change anything, I can't believe that it didn't, you know. So, Tom's fuel here is clear, but when we were in Vermont, it was
That's taxable
red.
fuel. The
Taxable.
red dummy is taxable.
And the fuel is very expensive now. Kerosene's over $2 a gallon, which it never used to be. But,
I don't think the dye itself should give you any problem, but when it has that dye in it, you can't tell what's in it. So it may be number one fuel oil or something instead of kerosene.
Well, they call it truck drivers using fuel oil. That's why. The
That's
state
why they
police
put the
now
dye
check,
in.
right. You gotta have the red dye and things.
and some places don't have it at all. And a lot of the tours will have to order kerosene ahead of time and have it stored somewhere in a fuel station.
Jeez.
So that if people come with cars that run on kerosene, they can have a fuel.
Tom, you need a Stanley tank truck.
Yeah.
This fellow that went from Alaska to Maine, did have with him.
Full of sugar.
Great car, yeah.
Did anybody ever converted one to propane?
There's a
Takes the fun out
very
of it.
sad and serious story about propane, Jimmy. It happened 40 years ago out in California. And actually the car had not been converted to propane, but they were in a parade at Knott's Berry Farm. And I don't know whether they had a propane pilot, but anyway, they had spare propane tanks they were carrying back in the tonneau of the car. And it was a very hot day, and I don't know whether tanks like that are supposed to have a safety valve or what, but apparently they did. Safety valve let go, and somehow that propane ignited. 4 people in the car were seriously burned. The owner and his wife lost their lives. There were lawsuits all over the place. AACA was sued. High Ballard had to defend the suit on behalf of the club, I remember. I think it was an AACA sponsored event. That was the problem there, or the reason they got drawn in. And really, so many people will ask you, do you burn propane? And they kind of shy away. No, we never burn propane. But I've known people who have used propane for their pilot light, that's all. I never knew anybody. But because of that accident, I was at Disney World as part of a tour one time in Florida, and there were 2 steamers on the tour, Brent Campbell and myself, and there were, I guess, about 40 gas cars on that tour. And we were supposed to have a parade down the main street of the Magic Kingdom. And safety man came along and said, well, we can't let the steamers in there. And I wasn't particularly disappointed, but Brent Campbell was very disappointed. And he knowing Brent, he persisted, and finally got to talk to the safety director, and we told him we can get through the parade without any fire at all. We'll fire up out here in the parking lot and have enough steam. Well, he said, you sure of that? And you have no propane on the car. So he said, all right. So I was firing up, and Brent was already firing up, and just before the parade started, the man came back. He said, I'm awful sorry, but the top man has said no steamers in the parade. And it all happened because of,
Yeah.
Disneyland and Knott's Berry Farm close together out there. They knew about it, and they had this mindset that it was a very dangerous thing. So anyway, that's a long answer to your question. Did everyone ever convert to propane?
Here's a little cover for the peephole. It's right on there like that with a bolt through it, and then it can open, and you can see through and close. Tom said he'll light the pilot on one of the cars for us tonight. He's going to get a propane.
We got a torch down here, Tom.
Got one, Tom.
Tom, they said they've got one.